Hi there, I'm Paul Belflam and this is Industrial Organization. The topic of this presentation is the formation and stability of cartels. We want to understand how cartels can form and why they are inherently unstable. For some background reading, please read section 14.1.1 in the textbook. Let us start by describing three different processes by which cartel can form. The first one supposes that firms decide in a simultaneous way whether or not they want to participate in a single cartel. So we have basically a two-stage game. In the first stage, firms decide whether or not they want to be in this cartel. And according to the collection of these decisions, we will have a cartel with a certain number of firms and other firms which decide to stay out. So that determines the number of separate decision makers. And from there, we can analyze the second stage, which is the competition on the market. Alternatively, we could assume that firms form the cartel in a sequential way. Then we would have not just one first stage, but a succession of decisions made by firms. One firm may propose other firms to be in the cartel. These firms will either accept or reject the offer, and if they reject it, they may make a proposition of their own. Okay, and so we have a sequence of decisions at the end of which potentially a number of different cartels can form. And again, from this procedure, we will determine how many decision makers there are on the market when firms decide either to choose quantities or to choose prices. Finally, the third process by which firms could form a cartel happens in different situations where firms can be assigned to a particular market, think of different countries, for example, or different market segments. Okay, some firms serving, for example, businesses and others serving consumers. Well, if each firm can be associated with a particular market, then firms may decide through bilateral agreements, which are called market sharing agreements, they may decide to stay out of the market of another firm if this other firm stays out of the market of the first firm. Okay, and so if you collect all these bilateral market sharing agreements, you will have at the end of the day a network of collusion. So that's another form of collusion that can happen on different markets. Okay, in this presentation, we focus on the first form, the simultaneous formation of a cartel. We'll say a few words about what happens if the cartel is formed in a sequential way, and we leave it to an activity for you to discover what happens in the third form when firms form bilateral market sharing agreements. Right. So let's look at the model, and we start with a simple model with three firms. As I announced, we have a two-stage game. In the first stage, the firms choose either to participate in the cartel or not. If they do participate, they say yes. Otherwise, they say no. That determines how many firms will, at the second stage of the game, make independent decisions. Okay, and we will assume, and this is the purpose of the cartel, that the cartel is a unique decision maker. This is the coordination of decisions that we talked about in a previous presentation. Let's assume that the market conditions are as follows. The inverse demand is given by this linear function, P is equal to A minus Q. And we assume that all firms are the same in the sense that they have the same marginal cost, which is constant, and which we call C. It's important to remember that when firms are in a cartel, they just coordinate the decisions, but there is no effect on their production costs. Okay, so the cartel will be seen as one firm with the same marginal cost, C. Okay, in what follows, we set A minus C is equal to 1 just to make our computations a bit more simple. Okay, now on the market, we will assume that there is co-no competition among independent decision makers, and I let you check that under a duopoly, if there are two decision makers, each decision maker will make the duopoly profit 1/9. If the three firms remain independent, we have a triopoly, and the profit of each firm would be 1/16. And if they are all in the cartel, then it's a monopoly. and the profit of this monopolist would be equal to 1/4. Okay? Now, this is all we need to try and find the Nash equilibrium of this two-stage game. This is here a representation of the first stage, and this will determine how many different subgames we have in the second stage, which is a quantity game. Okay, but let me first explain what this picture means here. We've got three firms, and this is the way to represent the normal form game of a game with three firms. Okay, firm 1 is choosing the lines, firm 2 is choosing the column, and firm 3 is choosing the matrices. Okay, and all three firms at the first stage of the game, they've got a binary decision to make, which is either to accept to be in the cartel, this is yes, or refuse to be in the cartel, which is no. Okay, so for example, in this cell of the game, firm 1 says yes, firm 2 says yes, and firm 3 says yes as well. Okay, and in this case, they form a cartel with three firms, and there are no independent firm. And what is the profit that each firm will make? Well, together, they make a profit, the monopoly profit, and we assume that they divide this monopoly profit equally among them. So each of them makes a third of the monopoly profit, which is 1/12 in our case. And we call this pi in 3. So what does that mean? In the superscript here means that the firm, we consider firms in the cartel, and there are three firms in the cartel. This is the number we put here in brackets. Okay, so that's a situation where they would all have decided in the first stage to be in the cartel, and so at the second stage, each of them would collect a profit of 1/12. Now, let's look at situations where only two firms say yes. Okay, and that happens in these three cells here. There is always one firm that says no. Here it's, in this case, this is firm 2, in this case, this is firm 1, and in that case, this is firm 3. Okay, but as we've seen on the previous slide, all firms are identical. Okay, so what really matters here is the number of firms deciding to say yes or no, and their identity doesn't matter because they are all identical. Okay, so in these three situations, we've got two firms in the cartel and one firm that remains independent. So what are the profits that they will make at the quantity game at the second stage? Well, the two firms in the cartel, they will share the duopoly profit. So they get 1/2 of the duopoly profit, which is 1/18. So this is the profit of firms in the cartel when there are two firms in the cartel. And the firm that stays out when there are two firms in the cartel has the duopoly profit for itself, which is 1/9. Finally, there are situations where only one firm or zero firms say yes at the first stage. Okay, so to form a cartel, of course, you need at least two firms. So if only one firm says yes, it's as if none of them were saying yes, meaning that there are no firm in the cartel and the three firms remain independent. In that case, they've got the profit of the triopoly, which is 1/60. Okay? Now, what matters, what we are looking for is the equilibrium at the first stage. So the equilibrium in this game here. And we want to know what one firm is willing to do depending on the choices of the other two firms. Okay, so first question we ask, is it possible that the three firms will say yes in the first stage, meaning that there are three firms in the cartel? Well, each of them has to ask itself the following question. Given that the other two firms have said yes, do I want to say yes myself or not? Okay, which means, do I want to be in the cartel with these other two firms, in which case I'll have the profit of being in a cartel with three firms because I will be with the other two? Or do I prefer to stay out, to remain independent? In that case, I've got the profit of being out, and I'm not in the cartel, so there are only two firms in the cartel. Okay, so I repeat, the question is, do I want to be in or out? If I'm in, there will be three firms in the cartel, because I suppose that the other two are there. And if I'm out, I leave the other two firms in the cartel, but I'm not in myself. Okay, so if you use the numbers that we found on the previous slide, and just rewind the presentation if you want to check, the profit of a firm in the cartel with the other two firms is 1/12, but the profit of being out when two firms are in the cartel is 1/9, so this condition is not satisfied. The answer to this is that there is an incentive for each firm to be out of the cartel when it supposes that the other two firms are in the cartel, meaning also that there is no equilibrium with three firms being in the cartel. Okay, so first answer to the first question, can we have an equilibrium with three firms in the cartel? The answer is no. Right, so let's look at another possibility. Is it possible that two firms want to be in the cartel? Well, the first condition is that the firm which is not in the cartel doesn't want to join. Okay, and this condition is just the reverse of this one. Okay, we want to check whether a firm which is out of the cartel when two firms are in the cartel doesn't want to join them. Okay, well, we know that this inequality is not satisfied, so the opposite inequality is satisfied, meaning that the answer to this first question is yes. The independent firm doesn't want to join the cartel. Now, the question remains as to whether the firms which are supposed to be in the cartel don't want to leave the cartel in some sense and to stay independent instead. Okay, so in this case, the condition writes as follows. The profit of the firms in the cartel when there are two firms in the cartel should be larger than the profit of leaving this cartel, meaning that the cartel would collapse in this case as only one firm would remain in the cartel. Okay, so do I want to be in or out? If I'm in, I've got half of the duopoly profit, which is 1/18, and if I get out, I would have the triopoly profit, which is 1/16. Again, 1/16 being larger than 1/18, this condition is not satisfied. Okay, so I would have an equilibrium with two firms in the cartel if the firms in the cartel don't prefer to stay independent, but we have seen that they would prefer to stay independent. So again, we don't have an equilibrium with two firms in the cartel. Okay, so the only possibility that remains is that no firm is in the cartel. All three firms prefer to remain independent, and this is actually what happens here. We see that this inequality actually is reversed, which means that it's better to stay out of the cartel rather than to join another firm in the cartel. Okay, so in this specific game, the cartel will not form if there is simultaneous move. The cartel doesn't form. Okay, so we want to see whether this is particular to the case of three firms or whether this can be generalized to any number of firms. Okay, so this is what we do now. It's exactly the same game. We just need a little bit more of formalization. So let's call K the number of firms that are in the cartel. K can be anything between 1, strictly above 1, and up to n being the total number of firms in the industry. Okay? If K is equal to 1, this is the same as saying that all firms stay independent. Okay? So that's what happens at the end of the first stage. This is the same game as before. Firms say yes or no, okay, and the number of yeses is K. Okay, that's the size of the cartel. Now, what happens at the second stage? Either some firms remain independent, okay, so K is not equal to n, is strictly lower than n. In that case, we have a Kuno game, which is played by the cartel, which is a single decision maker, and the other firms that have said no in the first stage. So these are n minus k independent firms. Okay, so how many decision makers do we have for the Kuno game? We have the n minus k independent firms plus the cartel, which acts as one firm. So we have n minus k plus 1 decision makers. Okay, so this is okay for k strictly lower than n. If k is equal to n, so this is a situation where all firms decide to be in the cartel, then we have a single decision maker, which is this cartel that acts as a monopolist. Okay, we assume the same market conditions as before, the same inverse demand function, and the same cost, which is identical for all firms, and I let you check that if there are X decision makers on the market, each decision maker makes a profit of A minus C to the square divided by X plus 1 to the square. Okay, so this is something we explained at the very start of the course when we discussed about quantity competition. You can go back to your notes or to the slides or screencast to this week if you want to check that. Okay. Now, what is the condition? What are the conditions to have a cartel with K firms? When is this an equilibrium? Okay. Well, as we did with in the games with 3 firms, we want to check that the firms which are supposed to be in the cartel do not want to leave the cartel. Okay, so we're looking for a Nash equilibrium in the first stage of the game. Each firm, taking the behavior or the choices of the other firms as given, is asking itself whether it's really a best response to be in the cartel rather than not be in the cartel. Okay, so how do we write this condition? We write it as follows. Okay, so given that there are K firms in the cartel if I am in the cartel, when is it that the profit I earn by being in the cartel is larger than the profit I would be getting if I was out of the cartel? But if I was leaving the cartel size would no longer be K, but K minus 1. Okay, so each firm is taking into account the fact that if it leaves the cartel, the size of the cartel is reduced by 1 unit. Okay, so that's why we write K minus 1 here as a result of one firm leaving the cartel. Okay, now the rest is describing or developing this expression. Okay, so let me just repeat that the number of firms in the cartel is K if the firm I'm considering remains in the cartel, so that's the choice of saying yes. But the size of the cartel is K minus 1 if this firm deviates by saying I don't want to be in the cartel, by saying no in the first stage. Okay, now at the Kono stage, what matters is the number of decision makers, right? So if there are K firms in the cartel, there are N minus K plus 1 decision makers. I repeat, there are N minus K independent firms plus the cartel that acts as a single decision maker. Okay, so that's what we have here. We divide by A minus K plus 1 to the square. Okay, let me just go back quickly to the previous slide. Remember that at the Kono game, the profit per decision maker is A minus C squared divided by X plus 1 square, X being the number of decision makers. Okay, so this is what we have here. There are N minus K plus 1 decision makers, and this is what replaces X in the previous formula. Okay, now in the cartel, remember that they divide this profit, the profit of the decision maker, they divide it equally among the cartel members, so each one gets a profit 1 over K of this. Okay, now if the firm goes out of the cartel, that changes the number of decision makers. Okay, instead of N minus K plus 1, we have N minus K minus 1 plus 1. Okay, the cartel has now reduced size because one of the firm has left it. Okay, now how do we get to this next inequality here? Well, we have factored out or divided through by A minus C squared, which is in both expressions, and I'm just cross multiplying to get this formula here when I've also developed N minus K minus 1 plus 1 is equal to N minus K plus 3, and N minus K plus 1 is equal to N minus K plus 2, right? Now, I develop here by just developing these squares, keeping N minus K as a variable, so I've got N minus K to the square, plus 2 times 3 times N minus K, plus 3 to the square. And I do the same here, but don't forget that we need to multiply everything by K. Okay, and finally, this is the last inequality. I collect the terms in N minus K squared and in N minus K, and finally the last terms. Okay, and now I can say something about whether this inequality can hold or not. Okay. First of all, consider n being at least as large as 3, and by definition of k, k is no larger than n, when you can check that all the terms in this inequality are negative, meaning that it cannot be positive. Okay, so for example, if k is at least as large as 3, 9 minus 4k is negative, and the same goes for 6 minus 4k and for 1 minus k. Okay, so this is a first conclusion here that confirms that the case we saw with 3 firms led to a conclusion with no cartel forming, while this is true if n is larger than 3 as well. Okay, so that leaves us with 2 possibilities. Either k is equal to 2, so there are only 2 firms in the cartel, and n is strictly larger than 2. So if you replace k by 2 in this inequality here, and you just sum up the terms, you're going to reach minus n squared plus 2n plus 1, and you can check that this is negative for any n strictly larger than 2. So again, the positive sign that we needed here is not reached. Okay, remember what that means. It means that the profit for a firm in the cartel with k firms in the cartel is strictly less than the profit that this firm would obtain if it was leaving the cartel. Okay, so again, that means that we don't have a Nash equilibrium with k firms in the cartel. The last possibility would be that there are only 2 firms in the industry, and these 2 firms form the cartel. In that case, if you replace n and k by 2 in this inequality, you get 1, which is actually larger than 0. So this is the unique case where this condition for stability of the cartel is satisfied, meaning that if we've got 2 firms to start with, and these 2 firms collude by forming a cartel, then this cartel is stable, but this is the only case under which the cartel is stable. Okay, we summarize this in this result. Under simultaneous formation of a cartel, so formation of a single cartel on a Kuno market with homogeneous goods and constant marginal cost, if there are at least 3 firms in the industry, all firms remain independent, no cartel of any size forms. But if there are just 2 firms in the industry, then the 2 firms form a cartel. This is the unique Nash equilibrium of the 2-stage game. Okay, so that underlies the fact that inherently cartels in a Kuno market, which are formed in a simultaneous way, these cartels are inherently unstable, meaning that they don't form. What is the main intuition behind this result? Well, it can be summarized by this phrase: it's better to be out than in. Okay, so basically, the outsiders are better off than the insiders. They prefer to stay out. Why? Because they're actually free rides. They benefit without making any effort. They free ride on the effort which is made by the insiders. The insiders, they reduce competition among them by reducing the quantity they put on the market. Okay, and remember what we saw in the presentation about coordinated decisions. The insiders reducing their quantities leads the outsiders to increase their quantities. So the outsiders take benefit of the fact that the insiders have reduced their quantities, thereby increasing price on the market. And because price is now larger, it's more beneficial for the outsiders to increase their own quantities. Okay, and so this is what I meant by saying that they free ride on the efforts of the insiders. And in terms of free riding, you know what happens. All firms prefer the other ones to make the effort. In this case, all firms will prefer the other firms to be in the cartel. But if all firms make the same reasoning, at the end of the day, no single firm decides to be in the cartel. And so cartel formation doesn't happen. Okay? So from a consumer's point of view, from the competition authorities' point of view, we should say this is excellent news. Okay? And certainly we need to keep in mind that cartels have this instability, which is very present. Okay, and so that reduces the risk of cartels forming. But we know from observing the reality that cartels do form. So that suggests that the model we have built here is a bit too strong. There are some assumptions which are too far away from what's observed in the reality. Okay, and so we need to extend a little bit the model to try and reconcile the model with what we observe in reality. Okay, and so what we have is that if you extend the model, for example, to products or goods which are not homogeneous but which are horizontally differentiated, then it's possible to see that some cartels may form. Okay, and the reason being that the competition is reduced, but also the free riding incentives are reduced as well. Okay, and so it's possible to find stable cartels comprising not all firms but a strict subset of them. Okay, and for this you need the goods to be sufficiently differentiated. Okay, another way by which cartel could form is to be in situations where firms are not deciding at the same time or without observing the decisions of the others whether they want to be in the cartel or not, but there is a form of sequentiality. Okay, and as I explained in the introduction of this presentation, you could model this by one firm making a proposition to others and saying, well, do you want to be in a cartel with me? And then the other firms responding to this offer by saying yes or no. And if they say no, they may propose another cartel to form with other firms. Okay, and at the end of this game of proposition and counter propositions, what is shown is that it's possible that some cartels will form, not with all firms, but some firms, the ones who propose first, may use this sequential game of proposition and counterproposition. They may use this game to commit of staying out of the cartel. Okay, so they can say in a credible way, I'm not going to join the cartel, and that will allow the firms that propose next to form a cartel without fearing that the firms that are in the cartel would leave it afterwards. Okay, so this is just to show that in reality, cartels do form if, for example, these conditions are fulfilled. But nevertheless, and this is why the first model was useful, it shows that there are always forces that may induce firms not to stay in the cartel. This is this instability which is inherent to the formation of cartels. Okay, so stable cartels may exist, but there is always this force towards instability. And let me just illustrate this with the one cartel that cannot be fought by any competition authority in the world because it's a cartel formed by different countries. Okay, and you probably have heard of it, the OPEC, the old production cartel, the cartel of oil producing countries. Okay, and I will let you read this on your own, but I just want to stress some sentences in this article. They say the cartels, the success of OPEC's deal will depend on several factors, one of them being the cartel's own checkered history of cheating such agreements. Okay, so there is a long history in the existence of the cartel of agreements that have been taken to reduce production, but these agreements were not respected by individual countries, which found it more profitable for them to increase their quantities once the other countries were reducing their quantity. So this is exactly the mechanism that was highlighted in the previous model. Okay, and you can read the same here. OPEC wants its non-OPEC counterparts to slash their combined output, so it would like the outsiders not to react by increasing their quantities. But in the article, they say that Russia has said it would join OPEC output cuts in the past only to renege. Okay, so the outsiders may say, well, we will agree to what you ask us to do, which is to reduce our production, but actually what they say is not credible because their incentive is actually to increase their quantity once the OPEC countries have decided to cut their quantities. Okay, so I'll leave you with this article, which you can read at your own pace. But for now, this is all I wanted to present. Thank you for your attention.